All right, let's do this. Good afternoon and welcome to our session, Automatically Scale a Serverless App with Amazon Comprehend, Textract, and MongoDB. My name is Ralph Capasso and I am a lead engineer at MongoDB.
Diana Esteves, I'm also a senior engineer at MongoDB.
Today we're going to show you how to build a serverless application using Amazon's machine learning and optical character recognition services. First, we're going to show you a cool app that we built. Then, we'll dive into how fast and easy it is to use Amazon's machine learning and optical character recognition services. Next, we'll show you how quick and effortless it is to build a serverless application on the MongoDB data platform. Along the way, we'll show you how we built the app, and at the end of the session, we'll send you home with the code. But before we do that, I need all of you to jump into my time machine with me. Come on, everybody in. And travel back to the year 2001. I want to talk to you about a company named Enron. Enron was an American energy, commodities, and services company based in Houston, Texas. In under 10 years, they grew to have a $65 billion valuation, which was unheard of at the time. Well, it was quite a feat. But let's just say this wasn't your typical fairy tale success story. By taking advantage of an accounting practice known as mark-to-market, Enron, along with their accounting firm Arthur Andersen, was able to manipulate assets and profits while hiding losses. This sent their stock price soaring and made them the toast of Wall Street. However, it all came crashing down when Enron reported shaky earnings in October of 2001. Subsequently, the Wall Street Journal began investigating two entities known as LJM1 and LJM2, run by the company's CFO, Andrew Fastow. This exposed a deep level of fraud at Enron and sent the company's stock price tumbling. As the plot unfolded, executives sold their stock and pocketed millions of dollars. In December of 2001, Enron filed for bankruptcy, which was the largest such filing at the time. It resulted in $70 billion in losses for its shareholders while wiping out the retirement savings and jobs for all of its employees. Head executives Jeffrey Skilling and Kenneth Lay were convicted of crimes in the case. CFO Andrew Fastow accepted a plea deal and testified against his former bosses to reduce his own sentence. Many lives were impacted. Many lives were ruined. The case against Enron took more than 4 years to build. It involved recovering and analyzing more than 500 boxes of paper documents and over 34 terabytes of digital files. So, what does this have to do with AWS and MongoDB? We're about to show you. Let's take a look at one of the key challenges in building a case against Enron, document research. Document research is difficult. Document research is time-consuming. Let's start our investigation by focusing on the corpus of Enron's emails at the time of their demise. More than 150 investigators combed through roughly 500,000 emails, taking more than 4 years to complete. That's right, more than 4 years. That's more than 1,920 working hours. In the next 40 minutes, we're going to give you the tools to make you smarter than the smartest guys in the room. As you can see, drawing relationships between emails and extracting information is no small task. All right, it's time to get back in the time machine and travel back to the present. Diloop, diloop, diloop. Welcome back to 2019. What if this happened today? What if we could apply machine learning? What if we could dramatically reduce the amount of time it takes to perform an investigation while gaining more from it in the process? What if we could bring the criminals to justice sooner and let our investigators have more time at home with their families? Diana will now show you the application we built to do just that. Diana Esteves, everybody.
Thank you, Ralph. As an investigator, it is my job to find incriminating data so that those behind the Enron scandal are properly charged. Walking around the Enron office in sunny Houston, Texas, I'd like to collect every bit of data so that it may be later on automatically processed. Here, I'm drawn to the shredder, where the surroundings suggests an attempt to hide several of Enron's files. With my mobile application, I'm going to snap a picture of these poorly taped up documents so that later on they may be processed. Once back at the office, I'm going to log in to my web application, Docket. Docket is a smart research application. With access to digital data, we've been able to collectively analyze over 500,000 emails. Thus, I can jump in and easily do the job of 20+ investigators. At a glance, no surprise, our top entities and key phrases in the entire data set are variations of Enron, the subsidiary companies, along with Houston, where Enron was headquartered. Down below, we have a number of research projects. A given research project consists of a number of queries an investigator ran together. Let's go ahead and create a new one and call it Project Stanley. Project Stanley was nicknamed after the hockey cup, and it involved companies in Alberta, Canada, which Enron worked with to inflate energy prices. So let's see if we can identify some relevant emails by running a query. Here we're going to select Project Stanley, and we know this happened in Alberta. If I'm unsure whether I need to find a key phrase or an entity, there's a powerful text search feature. So in here, let's go ahead and type in energy. Once I have all of my text, my filters in place, let's go ahead and inspect some documents. I here have all of my results. For each email, I have the top key phrases and entities on the left-hand side. Therefore, I don't need to go back and read the entire email contents. For each result, if I find it to be relevant to the Project Stanley case, I can label it as interesting. If it's irrelevant, I can mark it as uninteresting. Once I have enough of these labeled documents, I can go ahead and launch a background process. This process, what it'll do, it'll identify other similar emails to the ones I have selected. Let's go ahead and take a look at another project that has already been trained, but it still needs to be classified. Project JEDI. This was an acronym consisting of spin-off companies that Enron used to hide all of their losses. Looking at the JEDI project email here, we can see that they are discussing how to balance off their numbers. If it weren't for this application, and we were back in the year 2001, this will mean that I will have to task all of my junior investigators and ask them to find relevant emails manually. This application is very powerful because it allows for semantic search. As a result, I can identify and profile each individual accurately. So now I wonder, what's powering this application? Tell us, Ralph.
Thank you, Diana. As you just saw in the demo, the goal of the investigators is to extract incriminating evidence. We start with our corpus of documents. We then perform a basic analysis on those documents to identify the common entities and key phrases. So, how do we achieve this? Enter Amazon Comprehend. Amazon Comprehend is a natural language processing service that uses machine learning to find insights and relationships in text. With Comprehend, we can analyze data quickly, extract entities, key phrases, sentiment, syntax, and topics. Dramatically reduce the amount of time it takes to perform an analysis. Remember, this investigation took more than 4 years in the early 2000s. And my favorite part, no prior machine learning experience is required to use this service. Great. So we now have a way to analyze all of our electronic documents. But we need a way to process those paper documents that are hidden around the office. Remember, we recovered more than 500 boxes of them. To do that, we need to scan the documents and extract the text. Enter Amazon Textract. Amazon Textract is a service that automatically extracts data and text from scanned documents. Perfect. With Textract, we can extract data quickly and accurately, eliminate manual effort, lower our document processing costs, and no prior optical character recognition, or OCR, experience is required. Put these together, and we now have a solution for analyzing all of our documents. However, we need a place to store the digital files for these, which can be in text, image, or PDF format. Enter Amazon S3. As most of you know, S3 is Amazon's scalable, highly available, and secure storage service. So let's connect these together, starting with S3 and Comprehend. We take our document corpus and we upload it into an S3 bucket. We then feed the documents to Comprehend via S3. Comprehend runs an analysis and identifies the entities and key phrases within all of the documents. Simple as that. Now let's add in support for our scan documents using Textract. Using a capture device such as a scanner or a mobile phone, we snap an image of a document, feed that image to Textract, and Textract returns the text. Easy as can be. We will now demonstrate S3, Comprehend, and Textract in the AWS console. Take it away, Diana.
Thank you, Ralph. So we now know which AWS services we'll be using. So let's go ahead and see each of them in action. First, we have S3. S3, as we all know, is the first stop for any kind of large file dump. And the Enron dataset is no different. Let's take a look at what that looks like. So here, I'm just going to list the documents of my bucket. And in particular, I'm going to look at Kenneth Lay. Kenneth Lay was one of the founders and chairman at the Enron Corporation. So here, we can get familiar with the directory. And now let's take a look at a particular email. So here, I'm just going to copy a random email to my local machine. And now let's take a look at the contents. Great, now we have an automated way for me to start reading emails. Here we see the header information and the body, but I don't want to spend the next 4 years of my life reading through 500,000 emails. Instead, I want an automatic way to identify whether or not a given email is relevant to the Enron scandal. And as Ralph mentioned, this is where Amazon Comprehend comes into the picture. Comprehend works by taking in text input. That input is then fed through various analysis models. The analysis models can be built-in or custom. I will say that the custom one is very powerful, but does require a bit more knowledge about your data. Here, I've taken an article regarding Enron's sketchy annual reports, and with a single click, I am able to obtain all of the entities and key phrases in the original email. This text, the output for this is in JSON format, which will come in handy very shortly. For each finding, we have a confidence level, which is ideal for setting thresholds. Comprehend also offers an asynchronous options, which means I can specify a S3 URI and run and get back a job ID. We were able to run the entire Enron corpus, that's over 500,000 emails, in a matter of hours, not years. So surely digitized text is not the only source of evidence. What about the images we took early on? This brings us to Amazon Textract. Textract works by taking in an image, such as PDF or JPEG or PNG, or a PDF. It then performs a smart OCR against it. And if there happen to be any forms or tables in the original image, it'll make an attempt to extract those as well. So now you can see how this image will be first fed through Textract, and then the output of that will then be fed into Comprehend. So now that we know and we've seen how all of these services work, what do we do next? Back to you, Ralph.
Thank you very much, Diana. So we have a solution to collect our documents and perform analysis on them without launching a single server. Now the real fun begins. It's time to build our application. Let's see how we stitch everything together with MongoDB Atlas. Back to our diagram. We need a way to capture the output of these components and store it in a database. As you saw from the demos of Comprehend and Textract, the output format of these services is in JSON format. If only there were a database that could natively store JSON data without having to normalize and transform that data. Gosh. Oh. Well, hello there, MongoDB Atlas. Let's take a look at how we store data for our application. Here is an example of an email. As you can see, MongoDB makes this extremely easy. We parse the contents of an email and store them in a single JSON document. Here you will see fields for ID, author, and document contents. At the bottom, we have added a place for the output data from Comprehend. Unlike with a relational database, we do not need to create multiple tables and break up the data. We can store all of the information for each document in one place. This makes retrieving and working with our documents faster, more efficient, and quite frankly, a lot more fun. Here you see how the output data from Comprehend fits right into our email document without any alteration. This dramatically reduces the amount of time it takes to implement our research tool. And here you see how the same is true for the key phrase data. This makes Atlas the obvious choice for our database. So, what are we waiting for? Let's set it up. Take us to Atlas, Diana.
Sure thing. So here we are inside of Atlas, and the first thing we're going to do is build a new cluster. Atlas is available in all 3 major cloud providers. And of course, we're going to choose AWS. The next thing to do is to select the region that best aligns with our users. So let's go ahead with US West 2. Next, we get to configure our cluster details. Atlas offers a tiering mechanism where the lower tiers are great for development, but once the application is ready for production, dedicated instances are recommended. If we're unsure on which precise instance to start off with, what we can do is select the one that's most suitable and enable auto-scaling. Auto-scaling works with your storage or at the entire tier by looking at RAM and CPU usage. We can select our rules, and this will be the range of instances we're allowed to scale to and from. For our Enron dataset in particular, this made perfect sense because we had no idea how much output we were going to obtain from running Comprehend and Textract. So whether you're scaling manually, automatically, vertically up or down, there is absolutely no downtime. And that's because all of our Atlas clusters are highly available, which means we can upgrade one node at a time in a rolling fashion. With that, we move on to configuring backups. We all know backups are critical for any production application, yet this is often a cumbersome task that involves working with your DBAs, networking, storage team, and whatnot. However, with Atlas, it's as simple as a toggle. Now, we did leave the hardest part for the end, just what to name my cluster. How about this? This will take a few minutes to provision. And by the way, all of these provisioning actions can also be done via the Atlas Open Service Broker. Let's go to an existing cluster. All of our Atlas clusters are secure by default, which is the first great step towards avoiding ransomware and data breaches. What that means is all communication is done via SSL. In addition to that, if you want to talk to the cluster, all IPs need to be whitelisted. Furthermore, accessing the data requires, at the very minimum, users and passwords. From the countless benefits, I'd like to point out one of my personal favorites, the ability to pause a cluster, which greatly reduces your hourly cost. So I've definitely earned my extra latte this morning. So Ralph, now that I've configured a production-ready, auto-scalable Atlas cluster. Where do we go next?
Thank you, Diana. I'll show you. So you just saw that aside from being a great place to store your data, Atlas also comes with some really slick benefits. It's self-service and elastic. Launch a database with a few clicks and let it auto-scale up or down to meet the needs of your application. For our investigation, we don't know right away how much data we're going to collect, and we don't know how much compute power it will take to query that data. Atlas eliminates any worry about this by handling scaling for us. Global availability. Deploy your cluster across any number of regions across the globe. In our case, we're dealing with a domestic investigation. However, you can imagine that we need to have people on the ground in Houston and Washington, D.C. By deploying across multiple regions, even within the US, we can ensure that we have fast access to the data for all of our investigators. Enterprise security and SLAs. Atlas is loaded with enterprise security features, such as Active Directory support, customer-managed encryption at rest, network peering, and database auditing, to name a few. This is a sensitive investigation, and we need to be able to sleep at night knowing that our data is protected and locked down. In addition, as Diana mentioned, we need high availability. We're working around the clock here. With Atlas, all maintenance operations are automatic and require zero downtime. Comprehensive monitoring. Atlas provides monitoring of virtually every metric related to the database, its operations, and underlying infrastructure. Managed backup. I don't need to remind anyone here the importance of backup. However, I will note that in Atlas, it is a one-click solution that leverages volume snapshots for fast performance and provides point-in-time restore capabilities. And finally, Stitch. Stitch is contained within Atlas and provides serverless platform services. Much more to come on this one in a few. The best part, the majority of these features are available at all levels of operation, from the free database cluster to our largest offering. We have our database. Now we need to talk to the AWS components and store the results. We need a function to send our documents to comprehend, run the analysis, and store the data in the database. We need a trigger to maintain a view of the entities and key phrases across all documents, along with a count of how many times each one occurs. And we need a function to send our scanned documents to Textract, extract the text, and save it to the database. So let's take a look at how we build a Stitch app, let's take a look at how we launch a Stitch app and build these. Passing it back over to you, Diana.
Thank you, Ralph. So here we are inside the Atlas Stitch interface. As Ralph described, at this point, we've identified all of our AWS services, and we have configured our database. Now we need to coordinate both of them. For this, we're going to use Stitch. Stitch allows us to create server-side JavaScript functions to orchestrate data between clients, services, and MongoDB. In particular, it also offers a generic AWS service. So with this service, we can call out to S3, comprehend, Textract, as well as many other of AWS services. Let's go ahead and configure AWS in Stitch. The first thing we want to do is store our AWS secret in a safe place. So for that, we're going to create a secret, which we'll reference shortly. To configure AWS, all we have to do is add a service, give it a name, provide our access ID, and reference the key we just created. Now let's go ahead to one that's already configured. Now, because the AWS service is rather generic, we offer the ability to create rules. These rules will control which services is Stitch allowed to talk to. Not only that, but for each given service, we can control which precise actions can Stitch call. So now that we have configured AWS, let's see it in action. We're going to go over to our functions, and one of our functions is to upload an image. In here, we see S3's put object exactly as you would expect. And that's because Stitch uses the same name and casing as defined in the AWS SDK. What about Textract? Let's take a look. Here, we're calling the Textract service from AWS, and in particular, we're calling the tech document text endpoint. Now, this will run in asynchronous fashion, which makes sense for our use case because the user is uploading an image and we're getting the results right away. So the caller of this function can then insert those results inside of Atlas. But what about Comprehend? Comprehend is going to run against 500,000 emails. Therefore, I want to do this in an asynchronous fashion. So for that, we are going to use the asynchronous endpoint, which takes in an S3 URI. Now, the result of this will be a job ID with a status. So how do I know when my job has completed? Comprehend does not use SNS. However, fortunately enough, Stitch offers triggers. One of these triggers is very similar to a cron job, which means that every 20 minutes, I am going to call one of my functions, and this function will, in turn, check whether or not my job has completed. So with very little code, I've now wired up my backend pieces. Let's continue on to our research application. The web application was written in Vue.js, which is a popular front-end framework, and the mobile application in Swift. To use Stitch within these applications, I have to have the npm module or the iOS SDK for Stitch, respectively. Configuring Stitch within my application is done with 2 steps. First, I have to provide my application ID, which you can see right here. The second is authentication. Stitch offers a number of authentication mechanisms. In our case, we're using email and password. Once I've configured Stitch, not only can I start calling my serverless functions, I can also directly run MongoDB queries within my application, which means I don't need to go ahead and configure an additional MongoDB driver. To call a function, we use the call function method. It takes in as input the name of the function, along with any parameters it may need. So with Stitch, MongoDB's backend as a service solution, I was able to coordinate Atlas and MongoDB. There is no need to build any complex REST API, as I can call my functions and queries directly within my application. Ralph, I think I'm finally ready to start crunching through those emails. So what should we do next? Back to you.
Thank you very much, Diana. As you just saw, Stitch is a powerful serverless platform that is natively integrated with Atlas. It allows us to rapidly implement our research tool, which in turn greatly reduces the amount of time it takes for our investigation. To keep it in perspective, the sooner that we can bring the criminals to justice in this case, the sooner we can compensate our victims. Let's take a look again at what Stitch brings to the table. Functions. Define and execute server-side logic for your application without launching a server. Hosting. Host, manage, and deploy your application's static media and document files. Triggers. Execute application and database logic in response to an event or on a predefined schedule. And query anywhere. Query data in your database via your client application code without the need to build a web service layer in between. In addition, Stitch makes the life of a developer easier. It has native integration with the AWS SDK. You may have noticed this in Diana's code, but you do not need to import any special libraries to use AWS services. They just work. It provides a strong command line utility that makes it easy to create and manage projects. It also allows you to write your code locally and deploy it quickly. Finally, Stitch is natively integrated with Git, so you can leverage your existing development workflows and source control management processes. Everyone here is familiar with serverless components. Many things, such as what we've seen with machine learning and optical character recognition, along with authentication and analytics, to name a few, have been made into easy-to-use modules. However, in many cases, to use these still requires standing up servers and running services to interconnect them. Stitch completely eliminates this layer. It allows you to marry these components together and tie them back to your database without launching any infrastructure. After plugging in all of these components, we quickly realize that MongoDB is much more than a database. It is a serverless data platform. You get a client-side database bundled with hosting for your mobile, web, and IoT embedded applications. You get a suite of application development tools which allow you to define rules, create serverless functions, deploy code, and sync data between your client application and database. All of this sits atop a powerful data layer where you get a hands-free database with Atlas, full-text search capabilities with Atlas Search, and the ability to store vast amounts of data in S3 and query it with Atlas Data Lake. So let's finish up our application. You will recall that we have a web-based research tool. In order to get that tool into the hands of our clients, we need to host it. We'll do that with Stitch Static Hosting. We need to make the data searchable. We achieve this with Atlas Search. And we need the ability to query data directly from data in our database directly from our client. We achieve this with Query Anywhere. It's time to put the remaining pieces of the puzzle together. Diana, will you please do the honors and power up our web application?
Yep. My application finally compiles. I'm now ready to share it with my users. All I have to do is drag and drop the compiled files inside of static hosting within Stitch. Stitch also offers the GitHub service, as Ralph mentioned, which means I can configure it to react to repository changes to automatically deploy my application. Now, because the static URL provided by Stitch can sometimes be hard to read for your end users, you can also provide a custom domain via CNAME DNS records. Now, we know inside of these compiled files, there is code to call MongoDB functions, as well as to directly query our database. One of those functions, in particular, is the ability to perform text search. Text search is known as Atlas Search. Atlas Search is backended by Lucene. Lucene works by tokenizing text input and delimit it by whitespace, for example. We then take those tokens and apply a number of filters against them. For example, we can convert these tokens to lowercase, or we can ignore it altogether if it's a stop word in the English language. Part of creating a text search index first involves understanding the content better. So for that, we can use the Atlas Data Explorer to become familiar with our data. Here we have our documents collection, and we have the JSON documents that Ralph showed you earlier. So from looking at this document, what are some of the fields we may want to index? Right, so probably the author, the email contents, and the results from comprehend. Now that we know which fields to index, we can go ahead and build our index. So here we have the fields that we're interested in, and most of these use the Lucene standard index. However, there is one field where I know for a fact that the value of that field will always be a single word. Therefore, it makes sense to use the keyword analyzer. Now that I have built my index, let's go ahead and use it inside of a Stitch function. To use this index, I use my search beta aggregation pipeline, followed by any other filters I may want to apply to my query. Now, why did I do this inside of a function? Well, if my data model changes, or if I have new requirements for text search, all I have to do is update my function without having to redeploy the application code. Using Atlas Search means there is no need to export my data somewhere else. Instead, the index data is kept in the same secure location, MongoDB Atlas. Now back to you, Ralph.
Thank you, Diana. So one additional feature I'll point out. In our app, you saw that investigators can identify a subset of interesting documents and use those to find additional documents of interest in our corpus. We achieve this using a custom classifier in Amazon Comprehend, which Diana touched upon in the AWS console demo. So, with our application up and running, we are now sitting atop a rich data set loaded with analytic data. So what if we want to gain some additional insights? Well, we can create some great visualizations using MongoDB Charts. And if we want to dig deeper into our data, we can use Compass, which provides a robust desktop client for accessing your data and allows you to build complex queries with ease. They say a picture paints 1,000 words, so let's take a look at how easy it is to create some great visualizations using MongoDB Charts. Diana, show us how it's done.
Here we are inside of MongoDB Charts. MongoDB Charts, it's available in all Atlas clusters, including the free tier. It allows us to create visualizations, which is critical for any data platform. Here we have a dashboard, and these graphs are exactly the same graphs you saw in the web application earlier. A dashboard can contain any number of charts. So let's go ahead and create a new chart. Now, because I know my collection contains a lot of documents, I'm going to enable the sample mode and select my data source. There are a number of types of different charts available. So once I pick the one that I think makes sense, I just have to drag and drop the fields into my X and Y axis, or depending on the chart type. This will then give you a preview of the chart right here. Once we're satisfied with it, we can go ahead and save it. Now, how do I take this chart and put it inside my web application? I have to embed it somehow. Charts offers a way for you to directly embed this in your application. If it's sensitive data, then we can request a verified signature. Either way you go, all it takes is a single line of code to embed a picture inside of my web application. Now back to you, Ralph.
Thank you, Diana. So what can we take away from our Enron investigation? Well, data is power, isn't it? The truth about what happened at Enron was buried in the data. It was there all along. Putting that data into a searchable format, well, that's powerful. If we can navigate through the data, we can start to learn from it. Applying machine learning, extracting metadata, reviewing that metadata, and searching that, well, that is untouchable. Remember, the sooner we can bring the criminals to justice, the sooner we can help our victims. So, let's take one last look at our architecture. Without launching a single server, we stitched together components from AWS and MongoDB that allow us to collect a large number of digital and paper documents using Textract to extract the text from scans of the paper documents, identify entities and keywords for those documents using Comprehend, host our application using Stitch static hosting, make our data searchable using Atlas Search, find similar documents in our corpus to help build our case using a custom classifier in Comprehend, and build great visualizations using MongoDB Charts. So now that we know how everything works, let's take one last look at our application. Diana, bring us home.
All right, so here we go, back to the application we saw at the very beginning. Now understanding everything that's happening behind the scenes. First, we have our custom domain, so we know this application is being hosted inside of Stitch. Then we have the username and password, and we know this is being powered by the Stitch authentication. After I log in, we see the graphs that were put together in a matter of minutes with MongoDB Charts. At the bottom, we have our various research projects. If we go ahead and create a new one, we now know that the key phrases and entities came from running all of our emails through Amazon Comprehend. There is also the text feature, which we now know it's backend by Atlas and Lucene. Once I go back to an existing project and open it, we see the key phrases and entities for that particular email. We know that we can tag emails as interesting or not, which behind the scenes is running a comprehend custom classifier that allows us to label the training data. Once we have enough sufficient training data, we can launch another process to classify other emails. So you may be wondering, how many engineers did it take to put this application together? Well, this was put together by 2 engineers over the course of 3 weeks. One of them even went on vacation. Overall, the development cycle has been greatly reduced and user experience enhanced by using features such as my AWS services, Comprehend, Textract, S3, as well as features within Atlas and Stitch, such as the static hosting and MongoDB Charts. Now back to you, Ralph.
Thank you, Diana. So what are some other things we could do with our application to continue to iterate on it? Well, we could add functionality to our mobile client, similar to what we have in the web client, where we could make documents searchable and allow you to flag things as interesting. We could build additional charts and visualizations using MongoDB Charts and embed those into the application. We could analyze the search queries of our users and find new and exciting ways to present our data. We can create APIs so that other systems can leverage the functionality of our application. We can even integrate with email such that you could forward an email with a PDF document to an email address where we could extract the text, perform analysis, and add it to our document corpus. The possibilities are endless, and we encourage you to use your imagination. So let's quickly review the benefits of this stack. With Atlas, we get a database that gives us the ease of storing and querying data, all hands-free. Comprehend provides us with powerful machine learning capabilities that has adaptive tech to intelligently learn about that data. Stitch gives us a serverless platform with flexibility in state, along with the ability to call out to other services. And Textract takes OCR to the next level by identifying text in fields, forms, tables, and photos. Overall, MongoDB with Comprehend and Amazon Textract is extremely powerful. OK, now it's your turn. Try it for yourself. Take the handout from underneath your seat, clone the repo, claim your Atlas credits, launch your database. You even get a database free for life, and start coding. We're excited to hear what you create. With that said, we now have time for Q&A. So does anybody have any questions? Yes? Oh, there is not a handout under the seat, but you can photograph. They're at the door. They're at the door. Or I'll stand in front of the screen and you could take a photograph with me and the link. Any other questions? Yes, sir.
I guess the code line that you wrote was JavaScript code?
The serverless Stitch functions are written in JavaScript. The front-end application, it's JavaScript as well, and the mobile application is Swift.
The question is, can we use another technology or another language?
For Stitch, Stitch is written in JavaScript, but for the application that talks to Stitch, there are a number of supported languages available, yes.
Any other questions? OK. Well, thank you very much. On behalf of Diana and me, we thank you for taking your time with us, spending time with us this afternoon. We hope you enjoy the rest of your time here at reInvent. Happy coding and all the best. Thank you. Good night.
Thank you, everyone.